All right, folks, since you guys are now slope masters, we're going to finish off our chapter with writing equations of lines, which definitely uses the idea of slope. So again, hopefully some of these things are a review from your Algebra 1 course that you took. But again, I realize I don't remember everything from year to year, and I don't expect you two to completely remember either. But hopefully you've heard of slope-intercept form before. So let's talk about a few things here. So this is your slope-intercept form. You definitely want to write that down. So y equals mx plus b, where m is the slope of your line and b is the y-intercept. So again, maybe you want to put these arrows in your notes, but you want to definitely get this formula down. That's your y-intercept. All right, so slope-intercept form. Maybe you're forgetting what y-intercept is. That's where your line touches the y-axis. So if that's your coordinate grid, you had this line going through it, and let's say this point here was 2, so its y-intercept would be 2 because it touches the y-axis at 2. That's your y-intercept. Okay. Then another helpful equation or form of writing a line is the point-slope form, and it kind of tells you what it is. So point-slope form is when you're given a point on your line and the slope. So again, m stands for slope, and you're going to be given an ordered pair. So an ordered pair to plug into your formula. So that's your point. So we plug in your x1, y1, and your slope, and then from there you can solve to get it into slope-intercept form, or just leave it as it is, because that's an acceptable form or a way to write an equation of a line. So please make sure you have these two equations written down in your notes in the blank space where it says slope-intercept form and point-slope form. Let's try and see what this looks like, okay? It says write the equation of a line in point-slope form with the given slope and contains the following point. Then graph each line. Okay, so again, slope is our m, and then each point has an x1, y1. And we are plugging in, I'm going to shimmy this up just a little bit, if I can see here. I'm plugging into, can't lie. Can I drag it? No, I can't. 1 second, folks. This is kind of a mess. There we go. We're plugging into this guy right there, all right? So let's see what that looks like. So, do this blank space. You're going to have y minus, now what's our y coordinate? 5, equals our m, which we labeled -3/4, parentheses x minus our x coordinate, which is -2. So we know a minus becomes plus. So this is the point slope form of our our line that we're going to graph. So now we're going to graph it. You could solve this for y and then graph it using the slope-intercept form, but since we have the point and we can count our slope, I think that's probably the easiest for right now. So we're going to graph the point -2, 5. So somewhere right there-ish. And then we're going to count our slope -3, 4. So I'm going to go down 3 boxes, and then I'm going to go over right 4. Okay? So I'm going to go down 1, 2, 3, over 4. 1, 2, 3, 4. Put a dot. And do it again. Down 3, 1, 2, 3, over 4. 1, 2, 3, 4. And another one. 1, 2, 3, 1, 2, 3, 4. Okay, now if I want to extend my line going to the left, we're going to go up 3, 1, 2, 3, and then left 4, 1, 2, 3, 4. Doesn't it look like my points are still going to be collinear? Yep, there we go. And you do want to fill your whole graph with as many points as possible. And then since it's a line, make sure you connect them and put an arrow on each end. Perfect. Good work. Let's try another one here. Put this right here so we can see it. Again, my slope is m. Each ordered pair gets an x1, y1. Now we simply just plug in. So I'm going to have y minus our y coordinate is 2 equals our m, which is 5/8, parentheses x minus our x coordinate, which is -6. So minus really becomes a plus. And there we go. So I think that's not too bad. You guys can plug in just fine. And now we're gonna graph. I'm gonna use the same strategy I did before, and I'm just gonna plot my point, -6, 2. So somewhere right there-ish. Nice slope is up 5, right 8. So up 5, right 8. Here we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And I think that's all we can fit on here, folks. Just 2 points. So now, again, to finish off, connect your points. Make sure you have arrows at the end of your lines, and there you go. And you can always double check, right? My slope's positive 5/8. Is my line going in a positive manner? It sure is. Everything looks to check out. All right, flip it over for me. So now that we've talked about these equations of lines, you can just look at an equation of a line and determine if it is parallel, perpendicular, or neither to another line. So really, folks, the only thing you really need to focus on is your slope. We're just comparing slopes. And after yesterday, I'm hoping you guys are like slope kings and queens, because we did a lot of slope in that worksheet yesterday. So if we look here, do you guys see how y is alone? So y is alone, meaning it's in slope-intercept form, and our slope is in front of our x. So the slope of that line is 3. The slope of this line is also 3. So since our slopes are the same, hopefully you remember that means they are parallel. That one is parallel. All right, let's try another one. We'll go across. Here's my slope, -1/4. My slope on this one is 4, or 4/1. Anything special about -1/4 and 4/1? Yep, you should be thinking perpendicular, and I'm going to abbreviate and just put perp. Opposite reciprocals. All right. Now in this equation here, it's not in point slope form, and it's also not in slope intercept form, so I have to put it in one of those forms. The easiest thing to do, you guys, is just to get y alone. So that's what we have to do first here. You got to get y alone. So how do I do that? Well, I'm simply going to subtract over 3x to both sides. And I'm going to have 2y equals -3x plus 6. I am going to put my variable first because that's how your slope-intercept form is written. And then divide everything by 2. So then we should have y equals -3/2x plus 3. And you want to leave this as a fraction here, you guys, because that's how slope typically is written. So my slope on this one is -3/2. And my slope on my bottom line is -3/2. Anything special about -3/2 and -3/2? Yep, they are parallel. Good job. All right, let's try another one. So again, we don't have either equation in a form that's convenient for us, so we got to get them into a form that is convenient. So 3y equals 4x plus 15. How do we get y alone? Well, right now we're multiplying by 3. To get it alone, we divide. Divide everything by 3, folks. So y equals, 4 is not divisible by 3, so we're just going to leave it as a fraction. And there we go. So now our slope of that line is 4/3. Okay, let's try the next one here. Again, not in slope-intercept form, so we got to get this equation into a convenient form for us. So I'm going to subtract over 9x. 12y equals -9x plus 12. Last step, how do we get y alone? We simply divide by 12. Divide by 12. So y equals, can we reduce -9/12? Should be thinking yes. 3 goes into both of those, so -3/4 x plus 1. So if we look here, folks, we have a slope of -3/4 and +4/3. Those are opposite reciprocal, so those are also perpendicular. They're perp. Good work. Okay, I challenge you to try solve this next one on the left here on your own. So you can get y by itself all on your own and then compare with me. So it's kind of a weird thing that you haven't done probably in over a year or close to a year. Okay, I'm going to start it. Again, neither of my equations are in a form that's convenient, so we have to put them in one that works, aka get y alone so we can compare their slopes. So I'm going to start off by subtracting 3x over. We'll have 2y equals negative 3x plus 10. Our last step, to get y alone, divide by 2. So y equals negative 3 over 2x plus 5. So our slope on this bad boy is negative 3 over 2. Same thing on this guy. Get y alone. Minus 2x over 3y equals negative 2x minus 3. Divide by 3 to get y alone. Y equals negative 2 over 3x minus 1. So if we look here, folks, at our slopes, our first equation over here has a slope of negative 2 over 3. Our equation in the red here has a slope of negative 3 over 2. They are close to what we want. However, they're both negative, so this would be a neither situation. It's neither. All right, now finally, we got another weird one. So we haven't seen it in point slope form. You could distribute, the 1/4 and then get y by itself. However, you guys, if we look back at our equation here, where should our slope be? I kind of moved it around. But it's right here, right? Our slope is the m. This guy, so we don't have to do anything. It's already right there given to us. So if I look at our equations over here, our slope on this one is 4. Our slope on the second equation is negative 1/4. Anything special about 4 over 1 and negative 1/4? I hope when you're thinking they are perpendicular, because they are. All right, there's 2 examples I want you to add, either on the bottom over the summary or on the front cover, somewhere in your note packet that I want to go over really quick that wasn't in your packet. So it says, write the equation of a line in slope-intercept form that is parallel to the line y equals 2x plus 5 and goes to the point negative 3, 7. So we eventually want to get it in this form. We want to get y by itself. But in order to do that, we have to start with point slope form. And it looks more complicated than it is, you guys. It's not that bad. So if I want to be parallel to this line, what do I want my slope to be? I want my slope to be the same, right? So my slope should be 2. And I'm going through the point negative 3, 7. So I know I have an x1 and a y1. And now we just plug in. So I'm going to have y minus my y1 of 7 equals my slope of 2, x minus a negative 3, so it really becomes a plus 3. And now we do the process of getting y by itself. So I'm first going to take care of this parentheses over here. So drop down my y minus 7. 2 times x is 2x. 2 times 3 is 6. Now to get y by itself, I got to add 7 over to both sides. So we'll end up with y equals 2x plus 13. There we go. So you just wrote the equation of a line that's parallel to this line and goes to that point. Okay, one more similar to that. Same kind of process, but you want to write the equation of a line in slope-intercept form that's perpendicular to this line and goes to the point for negative 1. Excuse me, negative 9. So our slope, I want to be perpendicular to negative 2 over 3. I'm going to make it what? 3 over 2. And we're going to the point for negative 9. Here's my x1, my y1, plugging into the equation. Here we go. Again, plug in. Here we go. Y minus negative 9, so that's really like a plus 9, equals our slope of 3 over 2, x minus 4. Drop down that y plus 9. 3 over 2x is 3, or 3 over 2 times x is 3 over 2x. Ick. Now we have to take 3 over 2 times negative 4. Do it the easy way. What's 3 times negative 4? Negative 12. Divided by 2. It's negative 6. That's how I like to multiply by fractions. Break it apart. All right, last step here, folks. Subtract that 9 over. So we'll have y equals 3 over 2x minus 15. Thank you for watching that. That will help you on some of the questions on your homework. Okay, thanks for listening. Goodbye.